Hi, I'm Joe, and this is the first video in what I hope will be a nice series of tutorial videos introducing you to relational databases and eventually to Postgres as a specific database. Um, why you should listen to me on this topic is, well, I'll tell you a little bit about myself, and then you can judge. I was one of the first generation of web developers. I was making websites back in the 90s. I worked for a couple of big name companies, for a few small companies, and I have been using relational databases since I think 1999, so a little more than 20 years now. Through a series of adventures after the dot-com boom, I ended up in academia and got a doctorate. And I was teaching at two of what I think are the finest universities in the country. I taught databases classes and computer programming and agile software development, agile project management, um, as well as data analytics, statistics, and some programming classes. And so I've seen a lot of students struggle with these things in the classroom, and I have, I think, learned a few things about teaching. In 2019, I went back to software development. I'm doing what I love, and I am making sure that the stuff that I lectured about is stuff that I actually know. Putting my honing my craft and putting my theories to the test. So as a teacher and as a developer, I've used these databases for 20 years. I may not be one of the leading experts in the country, but I think I know a pretty good deal about these, and I would like to share what I know with you, and with your feedback, find out if it's any good. Okay, so in this first video, before we crack open Postgres, I want to talk about what is a database, why do you need it, um, and yeah, so database is a system for storing data. It is, and why not just store data in something like Excel, right? That's the first question. Excel is a great program. It's very powerful. It can certainly organize data and display it very well. A lot of people love it. A lot of people use it. It even has its own embedded programming language called VBA, so you can do really powerful advanced things with Excel. So why doesn't data management start and end there? So let me give you my little canned spiel. I've practiced a few times about data management and why we need something more than just a file. Okay, so data. What is data? Data means anything that is recorded fact, right? And so data, of course, exists outside of computers and has existed before computers. Maps and writing are data. Okay, but a computer doesn't exist apart from data. A computer is a machine that processes data. So what we're really talking about is digital data, okay, which could be on floppy disks on the network, right? And really has exploded since the introduction of the personal computer. But digital data consists of bits, okay, which are organized into bytes and files. And so bits are the little ones and zeros, which on a magnetic disk, it has to do with it's I don't know, it's a magnetic polarity. On an optical disc, it's a little piece of plastic that either allows the laser to pass through or doesn't allow it to pass through. In electronics, it's high voltage and low voltage. So as long as there are two states, if we have some way of indicating two states, that can convey information. And in binary, these can represent numbers, which can represent colors, sounds, and anything else. So that's all data. Bits, 8 bits is called a byte, and it's a fundamental measurement. You talk about megabytes and gigabytes and terabytes now, but it all goes back to these 8-bit chunks. And a file is just a chunk of bytes, okay? A chunk of bytes on disk, or that has a name and has an address in your file system. So files come in all different types. Okay, we have JPEGs, we have PDFs, we have MP3s, and we have Excel files, right? So Excel is kind of our competitor to a database. Okay, here's what's wrong with files, or the limitation on using files. And it's based on a story from one of the first places I worked after college. Okay, we had a mail order company in which people would call in, and we had these salespeople in the call center that would take their orders, and they would write their orders down on paper sheets. And these order forms would be picked up by data entry clerks who would type them into the computer. Now we can imagine that the file they were using was an Excel file, and it was very organized. Okay, and they'd put down, the customer's address, what he's ordering, credit card number, all this kind of stuff. That needed to go to a couple of consumers in the organization. You had a fulfillment department that needed to pack the orders, print the shipping labels, process the credit cards, and ship them. And you also had an accountant who would needed to pay the salesmen their commissions and, of course, record the revenue. Right? So this worked, but it has some complications. For example, day after day, you're either going to have one ginormous Excel spreadsheet, or you're going to have a lot of them. Day after day, week after week, month after month, year after year, you're going to end up with dozens, maybe hundreds of these spreadsheets. And if they stayed the same, if they never changed, that might be manageable. But here's what happens. Oh, I didn't even mention, multiple data entry workers. Let's go to this next slide. What if an order is returned or a credit card fails to be processed? Now there are different versions of the file. The fulfillment department has modified the file to mark the thing has been returned. He needs to share that information with the data entry person and with the accountant. Otherwise, they're going to end up with different versions of the file. Okay, and so in fact, there are 3 different versions because the accounting department, the fulfillment department, the data entry department, they all have their own copies, separate copies of the same file, and hopefully they are coordinating. But with hundreds of files, with lots and lots of changes, that becomes quite risky. Multiple data entry people is also another complication, right? Are they going to accidentally overwrite each other's work? Are they going to merge it together at the end of the day? Or are they going to have multiple files? But you're going to have a lot of these spreadsheet files. And then what happens is over the years, things change. Maybe the order form changes. You've added new products, you've changed prices, maybe you've added some new concepts like a membership number or a discount code. And so you change the spreadsheet to capture that information. So the spreadsheets from a year ago may look different than the spreadsheets from today. And if the new data entry person wasn't here a year ago, they may not even be able to read the old one, right? So you have multiple versions as well as multiple copies that are not coordinated. Okay, then you have accidental loss of data, you have fraud. By the way, there's no security controls on this. This spreadsheet has the customer's credit card number, okay, which not everybody needs, and yet there it is. And so over the years, these things become lost, or they become changed, or there's different versions and nobody remembers which one is the latest version. Okay. And then imagine someone else comes into the situation. Let's say you're a data analyst, you're an intern, and the boss asks you to make a report on revenue or something. You don't understand the spreadsheet. You find that there's a whole bunch of different versions of the spreadsheet that are structured differently. You can't find all the data. You don't know which copy is the correct copy. It's going to be very hard to come in. Okay, so files, even though they can be a very powerful way to organize data, they're limited, and their limitations mostly stem from the fact that there are multiple copies of them. Okay, it's hard for them to scale up. It's hard for them to coordinate. And they have this program data dependency, which is that only the person that sort of created the data knows how it was created and understands it. But there's just a ton of problems that come when you scale up to a large organization, lots of people sharing data through files. Okay, most of it stems from the fact that the file is only in one place. So the solution, okay, is you want a system that stands apart, that manages the data, and keeps track of just one copy of the data, and everyone else can go to that system for data. That's what a database is. That's why we need them. So you build this system with a database. What you'd have is a single version of truth. Okay, the database system sits there on a server on the network. Your data entry people put data into it. Okay, your accountant puts data in and takes data out. The way you communicate with the database is through what's called a query, okay, which sounds like a question. And literally, the accountant asks a question. Tell me all the orders that are either new or changed since the last time I looked at it. Shipping says, show me all the orders, just the name and address and the product um, that haven't been shipped yet. Okay, so you can structure queries like that. Um, it can enforce security, so it won't show the credit card number to people that aren't authorized to show the credit card number. Um, your salespeople are basically making an insert query, insert new order. And so whenever you go to that database, whenever the accountant goes or whenever the shipping person goes, they're always getting the latest version because it's only one copy. It's centralized. Your data entry clerk is now a DBA, so she's earning a lot more money. So she's happy about this too. But that's essentially what the database serves. It's that single repository that manages the data, that knows what it is. If you change the structure of your data, you change it for everyone, so no one is working with an outdated structure. There are no old spreadsheets that are in a different format. The database simply has to be sort of managed to hold the old data and the new data in some lowest common denominator format. What's more, and I didn't have it in this diagram, is that it's not just people that access databases with queries, it's also things like websites. So if you are building a dynamic website like an eBay, you're not going to code a different web page for every single product that some customer has added. What you're going to do is you're going to have a piece of code which generates the web page, and that piece of code is going to go to the database and say, give me the latest products, or give me the hottest products, or the products ending next. And the database gives it back to the program, and that program builds the web page and sends it to the user. Maybe this happens every single time someone comes to the website, right? Or maybe it's regenerated at intervals. But again, websites and online games and things like cash registers, all these systems that we have generally connect to some sort of a database on the back end. So who might you be? Okay, if you're interested in developing web pages, okay, learning how to design and query a database is going to be essential. Or if you're a business student, like the students I used to teach at the universities, um, you may be asked by your boss to generate a report. You may not be designing the database, but you're going to need to know how to query it. And you query a database with a language called SQL. So that's going to be a major topic in these presentations. Is we're going to teach you a lot of SQL querying. Or in general, I mean, this is probably the two main cases that brings you to this website. Either you're a web developer that wants to learn how to build a database back into your website, or you're someone who expects that you want to query the database. You may be a data scientist or an analyst that wants to just pull a chunk of data out of that business database in order to analyze it, produce charts, graphs, statistics, and what have you. So whether you want to be designing databases or whether you are given a database and you want to be able to work with it, I hope that by taking through these lessons, I'm going to help you get the tools to do that. And I'll try to make it a little more hands-on, a little less dry than, say, university lectures, because I'm not required to sit here for, 45 minutes or 75 minutes or some interval of time. We're just going to break this up into chunks on topics. So now you know what databases are, why we need them, why specifically relational databases I'll get to in a later lesson. But just know that the database I'm going to be using for these lessons is called Postgres, PostgreSQL, and it is one of the most popular open source databases. I like it a lot. I find it very elegant. And in my next video, I will show you how to install it in a relatively painless way using Docker.